Okay. Uh, so today we are going to discuss about simplified DS, which is nothing but the symmetric cryptographic algorithm. So when we are calling it as a symmetric, the same key is used for encryption and same key is used for the decryption. So this algorithm is also called as the private key cryptography. What does it mean? Like the different key, uh, not different key, but the sender and receiver is using the same key for locking and unlocking. So any algorithm contain the three parts. It's contain the key generation algorithm. Then it's having the encryption algorithm, and then it's having the decryption algorithm. So once you are aware of encryption algorithm, then it is quite easy to know the decryption algorithm. Moving on, the simplified DS is working on the 8 bits. It will be taking 8 bits of plain text and will have the two rounds, and it will be giving you the 8 bit of cipher text. So these are the given things with the algorithm, that P10, then P8, then IP, EP, and IP inverse. So what does it mean? These are nothing but the permutation operation and the like there are two operations used in this algorithm, permutation and the shifting operation. So first, trying to understand what do you mean by the permutation operation, right? Permutation is nothing but permuting the initial plain text into the another sequence, and that what sequence we have to follow, that is already defined by the algorithm. If you consider the P10, so permutation 10 is nothing but the 10 bit permutation, right? 8 bit permutation. It will be follow for 8 bit. Then again, P4 is again there for the 4-bit permutation. Then this is the initial permutation, expanded permutation, and the inverse of IP. So these all are the permutation operation defined by the algorithm which we will be using in the key generation and the encryption algorithm. Then the another operation you will find in simplified DS is substitution. So here the substitution box, two substitution box of name S0 and S1, each one of like 4 by 4 matrix has been already defined by the algorithm which we will be using. So starting with the key generation process. So this is particularly the key generation algorithm. So let's try to understand what this algorithm is, how it works. So it will be accepting initially the simplified DS will be accepting 10 bit of input key, and then it will do the permutation operation. So if talking about, let's say, the 10 bits are like this: 10101 11100, right? These are the initial 10 bits in like inputted by the user, right? So then as we know the sequence of this, right? This is the first bit, this is the second bit, this is the third bit, this is the fourth bit, this is the fifth bit. Then uh, like you have to start from, this is the first, second, third, fourth, fifth, 6, 7, 8, 9, 10, 10 bit, right? And if you want to apply the permutation of 10 bit, right? So you in new, after permuting this, how the things will be there, the third bit, okay, from this the third bit is 1 2 3 1. 1 will be the first bit, fifth bit will be the second bit, right? So fifth bit is again 1, second bit uh, will be the third bit, so second bit is 0, right? The seventh bit will be the fourth bit, so seventh bit is 1, right? Fourth bit will be the next bit. 10th bit will be the next bit, right? First bit will be the next bit. Ninth bit will be the next bit, right? Ninth bit will be the next bit. Eighth bit will be the next bit, right? Eight will be this, right? And the sixth bit will be the last bit. So sixth bit is 1. So like this permutation. This is nothing but the permutation, right? I hope the permutation is quite clear to all. So every time different permutations we need to apply. It may be P10, P8, IP inverse initial permutation, expanded permutation, and inverse of initial permutation. So what we have to do, we have to take the input bit of 10 bit, then we have to apply P10. And next, looking at the diagram, we will come to know we have to divide that into two parts. Left shift, the 5 bit each, right? Left 5 bit together, left half and the right half. Then next operation is left shifting by 1. Now, if you consider, if I want to consider this, right? This will be my first half, right? And this will be my second half. To convert that, right? So how the things will go? This 1 will go here, this 0 will go here, this 1 will go here, this 0 will go here, and this 1, the first one will go here. In similar way, we need to do the shifting operation for the same. Once we are done with the left shifting by 1, then we have to do the P8 permutation 8. P8 we have to apply. So observing this diagram very carefully, this is something will show 10 bit input. This particular P8 uh, will be taking and giving the 8 bit. So 2 bits are getting eliminated. Which 2 bits are getting eliminated, that will be uh, given in the P8 permutation. So after P8, the first key we will be getting, that we will call as the K1. Then moving on, left shift, we have done left shift 1, right? For getting key 1. So again, on the same input, we have to do the left shifting twice. So how you will be doing? You have to first do it left shifting by 1, again do it again left shifting by 1. So that will together will have left shifting by 2, the same operation. And then again merging together 10 bits and applying the permutation 8 will give you the K2. So this all is nothing but the key generation algorithm. I hope the key generation algorithm is clear to you. So now it's time to discuss the encryption algorithm in detail. Uh, Talking about the round operation, so I'll be uh, explaining this round terms with the help of analogy. Let's say your friend has sent you some gift, precious gift through the Amazon. So maybe it's a diamond set, diamond ring. So what Amazon will be doing, Amazon that that particular thing will be having itself a insider case, right? Lock into insider case wrapping, first round of wrapping with a particular key. And again, Amazon will be having the second wrap on the same, right? So the way in which the first wrapping is done, in the same way the second outer wrapping is done. Wrapping logic is same in both the cases. And if I ask you what is the relevance of having more wrapping up, right? So the more and more wrapping we are having, it will leads to the more security. Uh, and again, in reverse terminology, when the gift will get reached to you, you will be unlocking the outer wrapping first, outer round first with the same key, and then you have to unfold the insider round, right, with the same key. So try to understand the terminology round. That wrapping is nothing but the round. We are calling here it as a round. The more and more round you are having into the encryption algorithm will increase the complexity and the security aspect of your algorithm. So I hope this is round operation is quite clear to you. To make you understand, into simplified DS, here we will be having two rounds, and for each round we will be having a key. For first round we will be having the K1 key. For the second round we will be having the K2 key. So I'll be explaining you now uh, the algorithm in detail. So have a look on this particular algorithm. So the middle part is nothing but the key generation, where you will found this operation, um, permutation, shift, then shift, permutation, right? And this left hand side is nothing but the encryption algorithm. Now, looking at the diagram, you will come to know that initial 8 bit of plain text we will be inputting, and then we will be having the IP inverse of the same. Again, IP is nothing but the permutation operation, right? And that sequence is already defined, which we have to just use it. Again, the next you will found something like f of k. This f stands for Pissel structure, right? So you can map the analogy of wrapping logic, right? Wrapping of that box, locking of that particular box. So that is nothing but the Pissel structure. So this is the and Pissel structure is also called as the round operation. First round and the second round. The same operations will get performed twice. The only thing is that the key is getting changed. In first round, the K1 will be used. In the second round, K2 will be used. And you will find that in between the swap operation is performed. So don't worry, we will be discussing that in more detail. And at the last, you will be having again permutation operation, which is nothing but the inverse of IP. That will give you 8 bit of ciphertext. So looking at the diagram, so we have to here understand the f of k in detail. So if you see at the right hand side, this is nothing but the f of k. So we will discuss that in detail, f of k. Now, these all are, right? IP, EIP are the permutation operation, and how to do that permutation. The sequence is already defined. This is the initial permutation which we have used initially. Then this is the expanded permutation. So name itself indicates few bits will get repeated. Which bits we have to repeat? This is defined by the permutation operation, and the substitution boxes are defined over here. So now uh, coming back to the Pissel structure. So initially 8 bit of plain text we have to input to the algorithm, right? Then initial permutation we have to do. After initial permutation, you have to break down the 8 bit into 4 bit. So as you know, 4 bit together is called as a nibble. So we will be having left nibble and the right nibble. So looking at the diagram, whatever operations we will be performing, we will be performing it on the right nibble. The left nibble is kept unoperated. Okay. So till this point, right, till this point. So how looking at the diagram, what we are getting, first this right 4 bit we have to give input to the expanded permutation. So in the expanded permutation, 4 bit will get expanded to the 8 bit. Which 4 bits are getting repeated? This is defined into the expanded permutation, right? This is given. 4, like how to convert 4-bit to 8-bit is defined by the permutation operation. And then again, once you are having this 8-bit, this 8-bit are getting XOR with the first key which we are getting through this key generation algorithm. And then the next is again these 4-bit are again getting divided into 4-bit left nibble and the right nibble. So again here you will find the S0 and S1 is written. S0 and S1 are nothing but the substitution operation. So I'll be discussing the substitution operation over here. Uh, let's see whether it's getting first or okay. This is the substitution boxes which is already defined, okay, or which is already defined by the algorithm. We are just using that substitution box. So let's say this 4-bit, okay, this 4-bit is like this, 1101, okay, 1101. This 4-bit is 1101. So what you have to do, you have to take first and the last bit together, that will be the 11, and the middle 2 bit together, that is the 10. And this you are aware of. 00 is 0, 01 is 1, 10 is 2, and 11 is 3, right? This you know. So you have to go and see. 11 is 3, right? 3 and 2. In which substitution box you have to see? In S0, right? So you have to see this you have to consider as a row value, and this you have to consider as a column value. Column row column. So row will be 3 and the column will be 2. You have to go into S0 substitution box, then third row and second column, third row and second column. The value you will be getting is 3, and the 3 binary you have to replace over here with the 2 bits. So what replacement will be there for 1101? It will be 311. So looking at the substitution box symbol, you will be getting to know that this is shrinking operation. A substitution box will be taking the 4-bit input, and it will be shrinking that 4-bit to the 2-bit with the substitution operation. And for doing the substitution operation, you need the substitution boxes. So for this left nibble, we will be using S0 substitution box. For the right nibble, we will be using right substitution box. Once you are done with the substitution operation, then you have to that 2-bit together, 4-bit you have to permute with the P4. Once you are done with this P4 permutation, then that 4-bit you have to XOR with the unoperated left hand side nibble, right? And then you will be having the 4-bit as a left hand side nibble, and the initial 4-bit of initial right nibble you will be stretched down as a right hand side nibble. And then so now we are at here, right? We are at here, we need to perform the swap operation. Then left nibble will become right nibble, right nibble will become left nibble. And then again you have to do the same operation f of k, but here uh, in this point the k1 will get replaced with the k2. That is the only change. Okay, that is the only change. um, let's see this algorithm in detail. So see here, we are at here, right? what we will be doing, we will be shifting uh, left to right, right to left, and then same operation we have to perform. We have to again divide into 4 bit, then expansion permutation we have to do. That will give you 4 bit to 8 bit conversion and permutation. And then this time you have to XOR that with the K2. And then again substitution, same substitution operation you have to perform. And then after substitution, P4 we have to do, and then XOR we have to perform. At this time, this left hand side nibble you will be having as a second operand in the XOR operation. And then at the end, what you have to do, this left hand side nibble 4 bit after XOR, and the right hand side nibble you have to take as it is. Together will form the 8 bit. This 8 bit you need to again permute with the IP inverse operation. And after doing that IP inverse, that will give you the 8 bit of ciphertext. I hope it's clear to you now, the encryption algorithm. And if you observe the diagram very carefully, the decryption is inverse of encryption. So here we will be starting with 8 bit of ciphertext as an input. We will be doing first IP of that 8 bit ciphertext, then Fisher structure. Try to map the analogy of the Amazon. While doing decryption, we have to, while unfolding the gift, you have to operate on outer round first, right? And then inner round. So in the same way, the Fisher structure with the K2 we have to do, then swap operation, then Fisher structure with the K1 we have to do, and then IP inverse that will give you 8 bit plain text back. So that is all about this particular simplified DS.